Welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called clickjacking. This video is a technical deep dive of clickjacking vulnerabilities, and so it's going to be a long one. But by the end of the video, you'll have all the fundamental knowledge that is required to complete the 5 hands-on lab exercises that we'll be covering in the next upcoming videos. Alright, let's get started. The agenda for today is to first cover the technical details behind clickjacking vulnerabilities. So what is a clickjacking vulnerability? What are the conditions that need to be in place for an application to be vulnerable to a clickjacking attack? How common are these vulnerabilities, and so on. Next, we'll cover how to find clickjacking vulnerabilities from both a white box and a black box perspective. So if you're given an application and possibly even the application source code, how would you approach testing the application to determine that it's vulnerable? Once you've found that the application is vulnerable, how do you exploit the vulnerability to achieve your end goal? And then we'll end the presentation by covering the different techniques that you can use to prevent or mitigate clickjacking vulnerabilities. Alright, let's start off with the first section, which is what is a clickjacking vulnerability or a clickjacking attack. Clickjacking, or also known as UI redressing, is an attack type that fools a user into clicking one thing when the user is actually clicking on another thing. So this type of attack involves getting the victim user to think that they're interacting with a legitimate web page, but what is really happening is that there's a hidden UI for another web page that the user is interacting with without knowing. This type of attack could be used to perform a range of malicious actions such as installing malware, stealing user credentials, getting more users to click on your site so that it boosts ad revenue, and so on. Let's take an example to better understand how this attack works. Imagine you have a user that has logged into their banking application. In the My Accounts page, there's 2 buttons. The first one is to view the profile of the user, and the second one is to delete the account of the user. Now, if the user clicks on the View Profile button, it will present the user with his information, and if the user clicks on the Delete Account button, the account of the user is permanently deleted from the application. We're going to assume that this application is vulnerable to clickjacking attacks. Now, to conduct the attack, what the attacker first has to do is register a malicious domain, and in this case, the attacker chooses the domain catsite.com and uses an iframe element to frame the banking application and display it on his website. Now, the attacker is logged into his own account, and so you could see over here, it's loading the page of the attacker. The second step of a clickjacking attack is to overlay that iframe element with content that may interest the victim user. So over here, we add a div element and we overlay the application with a cat video and add 2 buttons to the application. One of them is the string go back, and the second one is the play video button. Now notice over here, the play video button is placed directly on top of the delete account button. Alright, we're done step number 2. Now the third step over here is to make the opacity or the transparency of the iframe element completely invisible. So it would look something like this. Now when you click on the play video button, what you're actually clicking is on the delete account button of the banking application. This completes our exploit. All we have to do right now is deliver it to the victim user. The attacker sends the malicious site to the user and tells him, hey, check out this cute cat video. And since no one can resist a cute cat video, the user checks out the site and then clicks on the play video button. And while he's viewing the video, what's really happening is that his account got deleted in the banking application. And that's pretty much how clickjacking attacks work. All you have to do is be able to frame the vulnerable application, then overlay the iframe with content that the user is going to want to click. And when the user clicks it, they're actually clicking on a functionality in an invisible application. Now you might be wondering, well, how is it possible that we're able to load the authenticated session of the banking application for this specific user over here? And the answer is that for this vulnerability to work, especially if it's in an authenticated page, the user has to be logged into the application. Now, when the user is already logged into the application and the iframe element asks the browser to frame the content of the application, the browser does not view this as a malicious action and loads the authenticated session of the user into the iframe element. And that's how we're able to get the user to perform an action in his own authenticated session because he's already logged into the application. There are a ton of real-world examples of clickjacking attacks, but majority of the famous ones targeted social media sites. An example of that is a clickjacking worm that affected Facebook and got hundreds of thousands of users to unknowingly post spam messages on their profile page. As mentioned in the article on this screen, the page warned users that clicking on the message will take you to an external page hosted by blogspot.com, which only displayed the text, "Click here to continue." However, although it appears to the user that they're just clicking on the "Click here to continue" button, what's really happening is that the attacker used an invisible iframe to load the user's active Facebook session, and when the user clicked on the page, what they're really actually doing is publishing a spam message on their Facebook profile. And so once you publish the spam message, your friends also see it, they fall for the same attack, which eventually caused hundreds of thousands of users to unknowingly post that message on their profile page. Now again, this is not a very harmful clickjacking attack because all it's doing is posting a spam message on your profile. However, in the presentation, we'll see how these attacks could become more and more serious and have much more impact depending on the goal of the attacker. Now, there are many different types of clickjacking vulnerabilities. The type again differs based on the end goal of the attacker. So for example, there's a clickjacking type called likejacking. This is a type of attack that aims to grab users' clicks and redirect them to likes on social media sites. This is similar to the example that we saw with Facebook, with the exception that we're not getting the user to post a spam message on his account. Instead, we're getting the user to like the Facebook page of the attacker. Another example is cookie jacking. This involves getting a user to perform a set of actions to provide the attacker with the authentication cookies that are stored in the browser. Of course, just like with the other clickjacking attacks, the user thinks that they're playing a game or performing another action when they're really sending their authentication cookies to the attacker. A third example is file jacking. This involves getting the user to give permission to the attacker to access their local file system and take their files. There are so many different types of clickjacking attacks. These are just 3 examples of them. Alright, so we covered the details behind clickjacking vulnerabilities and we looked at several different types of clickjacking. Now let's discuss the impact of these types of vulnerabilities. We've touched a bit on this in the previous slides, but as usual, when I discuss impact, I like to measure it in terms of how it impacts the SIA triad, so confidentiality, integrity, and availability. Now, when it comes to clickjacking vulnerabilities, the impact really depends on the goal of the attacker. So if we're talking about, let's say, a likejacking attack, where you get the user to like a page that they did not intend to like, then technically the impact is extremely low. You're only affecting integrity, and that's done for a very small part of the application, which is the like functionality. However, if you're performing a cookie jacking attack, that impacts confidentiality, integrity, and availability at a potentially high level if you're compromising the cookie of an administrator account. So the impact really depends on the goal of the attacker. Alright, let's discuss how common and critical these types of vulnerabilities can be. One way to measure that, and it's not bulletproof, is the OWASP Top 10 list. So for those of you that have not heard of the OWASP Top 10 project, it's essentially the list of top 10 most critical security risks facing web applications today. It's updated every couple of years, so you've got the 2013 list, the 2017 list, and the 2021 list, which is the latest one as of this recording. Now, clickjacking does not have its own category in the OWASP Top 10 list. It falls under the category Security Misconfiguration, which is considered the fifth most critical security risk facing web applications today. This is absolutely not a good indication for how common and critical clickjacking vulnerabilities are, because security misconfiguration covers a wide range of vulnerabilities and does not just cover clickjacking vulnerabilities. But from personal experience, what I can say is you used to find clickjacking vulnerabilities in pretty much every application that you tested in the past. However, nowadays it's very unlikely to find a clickjacking vulnerability. It's not impossible, but it's quite unlikely. This is because the defense for it is extremely easy, and it's usually just a matter of a configuration check in the framework that you're using. We'll talk more about that when we discuss the prevention techniques for clickjacking vulnerabilities. Alright, in the past section, we discussed what clickjacking vulnerabilities are, their impact, and how common and critical these types of vulnerabilities can be. In this section, we'll discuss how to find clickjacking vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing this application to see if it's vulnerable? I've decided to split this section into two categories depending on the perspective of testing. The two categories are black box testing and white box testing. For those of you that have never heard of these terms before, black box web application pen testing is when the tester is given little to no information about the system. Usually the only information that the tester has access to is the URL of the application and the scope of the engagement. Whereas for white box web application pen testing, it's the complete opposite. The tester would be given complete access to the system, including access to the source code of the application. Now, there is a third category that I haven't included on the slide. It's called gray box web application pen testing. This is a combination of both white box and black box pen testing, where the tester is given limited information and access to the system. So for example, instead of just giving the tester a URL of the application, the tester is also given accounts to the application. Now, when it comes to my methodology for finding clickjacking vulnerabilities, I loop both gray box and black box pen testing into one category. And that's because my methodology is the same regardless of whether you're testing in an authenticated page or an unauthenticated page. So for the presentation, when I talk about the black box perspective, what I actually mean is really gray box. We're going to assume we're given a URL to the application and accounts from each privilege level. And that's the most common type of testing that you'll encounter in the real world. All right, let's start off with a black box perspective. The first thing that you need to do is map the application. What that means is visit the URL of the application, walk through all the pages that are accessible to you within the user context that you're running with, and then make note of the response headers that the application is using. What we're looking for is defense mechanisms that the application is using to prevent clickjacking attacks. Now that's usually done using the X-frame options response header or the content security policy response header, or sometimes a combination of both. We'll discuss these headers in much more detail when we reach the prevention section. Now, in terms of the X-frame options response header, this header indicates whether or not a browser should be allowed to render a page in a frame or an iframe element. If it's set to deny, that prevents any domain from framing the content. And if it's set to same origin, that means only the current site is allowed to frame content. In both cases, this prevents other sites from framing your website, and so it makes it not vulnerable to clickjacking attacks. Now, the X-frame options header has a per-page policy specification, which means that it needs to be specified for every single page. However, most developers usually implement a filter that automatically adds the header to every page, and so depending on the implementation, you may have to check every single page of the application that has an actionable item to confirm that it contains the response header. but usually if it's implemented on one page, you'll see it implemented on all the pages in the application. Another defense mechanism that may be used by developers is the Frame Ancestors Directive in the Content Security Policy header. This directive is also used to indicate whether or not a browser is allowed to render a page in a frame or an iframe element. If you see it set to none, that means no domain is allowed to frame the content. And if you see it set to self, that means only the application itself has the ability to frame the content. Both configuration settings mean that the application is not vulnerable to clickjacking attacks. Now, the thing to make note of when it comes to the Frame Ancestors Directive is that it allows you to set specific domains that are allowed to frame the content of your application, and it does support wildcard characters. So it's really important to review that configuration and ensure that it's not set too loose and it doesn't allow random sites to frame your website. Now, if you find any instances where the X-frame options or the content security policy headers are set insecurely or they're not set at all, then the next step is to develop a proof of concept on a page that has an actionable item that could result in a negative impact to the application. All right, that was the black box testing perspective. Now let's talk about the white box testing perspective. The first step is to identify the technologies that the application is using. Most frameworks either have a built-in feature that allows you to configure security headers like the X-frame options and the content security policy headers. And if they don't have a built-in feature, usually you could just import a library that does that work for you. But in either case, all you really need to do is review the set configuration to determine that it's secure. If you do find instances where the configuration is not secure and it could potentially lead to clickjacking attacks, then all you need to do is develop a proof of concept and test it on a running application. And that's pretty much it when it comes to the white box testing perspective. All right, in the previous section, we looked at how to find clickjacking vulnerabilities from both a black box and a white box perspective. In this section, we're going to talk about how to exploit clickjacking vulnerabilities. So imagine you've been given an application, you've reviewed the response headers and determined that the application is potentially vulnerable to clickjacking attacks. How do you go about building your clickjacking exploit? As we've seen in previous sections, the main idea with clickjacking vulnerabilities is to include the vulnerable site in an iframe and then use CSS to overlap or mask that iframe with your malicious site. This might seem hard to do, however, clickjacking exploits are actually very simple to build. The exploit script that I have on the screen is from one of the labs that we'll be solving in the upcoming videos. The way the vulnerable application worked is it had a delete account button that allows you to delete your account by just clicking on that button. So our goal as the attacker is to frame the vulnerable application and to overlap it with our malicious application that just has the click me string on it. Now, when the user clicks on the click me button, what they're actually doing is clicking on the delete account button. So to construct this attack, the first thing that you need to do is to frame the vulnerable application using the iframe element. You could see over here, we've got the iframe element. We set the source to be the link to the vulnerable application, and then we close off our iframe element. Now, this will default to a very small page that is in an iframe, and so we want to make it bigger so that it's more realistic and easier to overlap our malicious site on the vulnerable site. So what we're going to do is use CSS rules to set the width and the height of the iframe, and then we use the opacity property to specify how transparent the application or the iframe should be. Now, we want the vulnerable application to be completely invisible so that the victim user has no idea that we're actually getting him to click on the delete account button in the application. And that's why we set it to 0.000001 because that essentially makes the vulnerable application completely invisible to the user. Now, the last property that we're going to set is the Z index. This determines the stacking order of the iframe and any other website layers. So the idea with clickjacking attacks is to have the vulnerable application at the bottom and then your malicious application overlap the vulnerable application. And that's why we set the Z-index to be equal to 2 for the vulnerable application. Now, everything in this iframe class will be applied on the iframe element. The next step is to place our malicious site on top of the vulnerable site. In this example, we're just adding the text click me in a div element and nothing else because this is just a proof of concept. However, in a real world attack, you would have to have a full-on application that seems realistic so that the user believes that they're actually clicking on items in that application and not on any other application. So we've got a div element that has the click me string in it. Now, all we need to do is make sure that click me string aligns with the delete account button, so that when the user clicks on the click me string, they're actually clicking on the delete account button. To ensure that it perfectly aligns, you need to set the top and the left properties. And then the Z index, which is again the stacking order, would be set to 1 because we want our malicious application to be on top of the vulnerable application. So you end up with something similar to this. All the user sees is the string click me, and when the user clicks on the click me string, what they're really doing is clicking on the delete account button. So you could see over here, the click me string overlaps perfectly on top of the delete account button. So that again, when the user clicks on the click me string, what they're really doing is clicking on the delete account button. The reason over here this seems invisible, whereas over here it's not very invisible, is because the opacity over here allows us to see the web page that is behind our malicious application, whereas over here we've set the opacity to be 0.000001, and that's why it's completely invisible to the user. Now, some applications may use client-side protection to prevent clickjacking vulnerabilities. These are usually called frame busting or frame breaking scripts. These scripts can do many things, like make all frames visible, prevent clicking on invisible frames, enforce that the current application window is the main or top window, and so on. The issue with these scripts is that they're considered to be a weak defense. And the reason behind that is because they usually can be circumvented by attackers. The way you would do that is by using the sandbox attribute in the iframe element. When it's set to allow forms or allow scripts, what it does is it allows you to neutralize the effect of the frame busting script and therefore be able to exploit your clickjacking attacks. We'll see an example of that when it comes to the upcoming videos. As you can see over here, in some of the labs, we're just clicking on a single button. In other labs, we're changing the email address of users. We're even bypassing weak defense mechanisms. We're performing DOM-based cross-site scripting vulnerabilities using clickjacking vulnerabilities. And then we're also performing multi-step clickjacking attacks. So you'll get plenty of hands-on experience exploiting clickjacking vulnerabilities. Alright, so far we only discussed how to do things manually. We can't end this section without mentioning web application vulnerability scanners. These are automated tools that crawl your web application and look for vulnerabilities. Now, since identifying clickjacking vulnerabilities is just a matter of looking at the response headers of requests, it makes it really easy for automated tools to find this type of vulnerability. I personally use Burp Suite Pro Scanner, which is paid. However, there are so many free and open source options out there that you could use. Now, the nice thing about Burp Suite Pro is that it has a feature called Burp Click Bandit, which is a point-and-click tool for generating clickjacking attacks. So remember the script that we saw in the past couple of slides? It'll automatically generate that for you, which I consider to be pretty neat. However, as we saw in the previous slides, writing a clickjacking exploit is very easy, and so you don't really need to use this tool if you're comfortable with writing clickjacking exploits. Alright, so that is it for the exploitation section. We discussed how to exploit clickjacking vulnerabilities from both a manual perspective and an automated perspective. Alright, let's move on to the last section, which is how to prevent clickjacking vulnerabilities. There are three main mechanisms that you can use to defend against clickjacking attacks. The first two we already touched upon when we discussed how to find clickjacking vulnerabilities. And the third one is more of a defense against CSRF attacks, but depending on the user context that the clickjacking vulnerability exists in, you may be able to use the CSRF defense to also prevent clickjacking vulnerabilities. The idea over here is to abide by the concept of defense in depth, where you have multiple defenses in place. Now, when one of these defenses is no longer effective for whatever reasons, then the other defense continues to keep your application secure. With each one of these defenses, we'll see that there are limitations, and so it's important to use a combination of defenses instead of just a single defense when it comes to preventing clickjacking vulnerabilities. We'll start off with the first defense, which is the use of the X-frame options HTTP response header. This header is used to indicate whether or not a browser should be allowed to render a page in a frame or an iframe element. It could be set to three possible values. The first one is deny, which prevents any domain from framing the content of the page. This is the recommended and most secure setting. The second one is same origin, which only allows the current site to frame the content of the page. This setting is also considered to be relatively secure. And the third one is the allow from directive. It allows you to specify the URI that is allowed to frame the page. So for example, over here, you could see that we've got legitimatesite.com is allowed to frame the content of the page. Now, the issue with this directive is that it's obsolete and it no longer works on modern browsers, which brings us to our next slide that covers the limitations of this defense mechanism. The first limitation is that the X-frame options response header follows a per-page policy specification. What that means is that it needs to be specified for every single page, which can be cumbersome and prone to errors. However, if you're a developer, you could just implement a filter that automatically adds the header to every page in the application. So there is a workaround to this limitation. The second limitation is that the allow from option is obsolete and is no longer supported by modern browsers. So if you apply this directive and the browser does not support it, then you have no clickjacking defense in place. This is something that you need to be absolutely careful of when you're using it in an application, especially if it's your only defense to clickjacking attacks. The third limitation is that there's no way to allow the current site and third-party sites to frame the same response. The X-frames options header does not support multiple values, which could cause issues depending on the functionality of your application. This issue could be fixed with the next defense mechanism that we're going to talk about, which is Content Security Policy Response Header. This header is used by developers or website administrators to control the resources that a user agent is allowed to load for a given page. The header is usually used to defend against cross-site scripting and clickjacking attacks. Now, when it comes to clickjacking attacks, the frame ancestors directive can be used to control who has the ability to frame a website. If it's set to none, then no domain is allowed to frame the content. If it's set to self, then only the current site is allowed to frame the content. Now, CSP also allows you to give permission to multiple sites or domains to frame your content. In the example on the screen, we're saying the site itself can frame the content. We're also saying any subdomain of the site somesite.com can frame the content of our application. And we're also including another domain over here called site.com that is allowed to frame the content of our application. Now, the most secure setting over here is obviously the first one, followed by the second one. If you do decide to set multiple domains and you are using the wildcard character, you should be really careful that your configuration is not too loose and potentially allows arbitrary sites to frame your content. So if you're a software developer, make sure that you secure the configuration when you're using multiple domains. And if you're a pen tester, make sure that you review the configuration that developers have put in place, because sometimes they do set it to be a little bit too loose, and so it allows you to register a domain or to use just any arbitrary domain to frame the content of the vulnerable application. Alright, the limitations associated to the content security policy is that the Frame Ancestors Directive is not yet supported by all major browsers, which is why it's important for you to use a combination of both CSP and the Xframe options header as a multi-layer defense in case one of the defenses is not supported by the browser that the victim user is using. Last but not least, we have same-site cookies. The same-site cookie attribute determines when a website's cookies are included in requests originating from other domains. This is usually used as a defense against CSRF attacks, but it can also be used as a defense against clickjacking attacks that exist within authenticated pages. It does not prevent another domain from framing your application. However, what it does is it prevents the browser from sending the authentication cookies of the vulnerable site when the request is originating from another domain. So the clickjacking attack won't work because you need the cookie to be sent for you to access the authenticated page that the clickjacking vulnerability exists in. Now, if the same site attribute is set to strict, that means the browser sends the cookie only in requests originating from the same site that set the cookie. And if it's set to lax, that means it's not sent in cross-site requests, such as in requests to load images or frames, but it is sent when a user is navigating to the origin site from an external site. So both these configurations over here will not allow cookies to be sent in requests made to a page within an iframe. But again, this is not the official defense to clickjacking vulnerabilities. It's just an extra defense that you could use on top of the two other defenses that we discussed earlier. Now, the limitations for this defense is that one, it only works for clickjacking vulnerabilities that exist in authenticated pages. If the clickjacking vulnerability is in an unauthenticated page, then this vulnerability will not work. The second limitation is that although the same site attribute is supported by most browsers, there is still a small number of browsers that do not support it, which is again why you should make sure that you apply a multi-layer defense approach instead of a single defense layer when it comes to preventing clickjacking vulnerabilities. Alright, that's pretty much it for the prevention mechanisms. We've reached the end of our presentation. I added several really useful resources on the slide in case you're interested in learning more about clickjacking vulnerabilities. The first two resources are the Web Security Academy and the Web Application Hackers Handbook. This presentation is mainly based on these two resources, and so I definitely recommend that you check them out. The third resource is the OWASP Clickjacking Defense Cheat Sheet, which covers in detail the defense techniques that we talked about in the previous section. And then the last resource is the Web Security Testing Guide, which covers how to test for a variation of web security vulnerabilities, including testing for clickjacking vulnerabilities. That's it for additional resources. In the upcoming videos, we'll gain some hands-on experience exploiting these types of vulnerabilities.